Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomechanical Engineering. So today class we are going to discuss about data management for an IoTs. Look at this diagram. This is an actual data management. Look at this. This is the data management layer. Look at this. This is the physical layer, communication layer. Second one. This is the middleware layer, and this is the application layers. Look at this actual data management is here. We have this event management. Again, this we have the data managements. So we have this filtering, aggregations. Again, this collections, processing. So recovery management, from this we have the collect the data and we perform this processing of that data. We can perform this filtering of operation. Again, that will be given for an aggregation. So from this will be given for an distribute data storages. So we have different disks to store the data, and here we have the resource management. So we have this resource registration, intelligent brokers, and resource identifications. So here communication layer we use so many communication protocols: Wi-Fi, Bluetooth, 4G. There is an interconnections, Zigbee, MQTT, again APIs, all other communication protocols. We have the physical connection. That is an application we have using the devices. And this is an application like application softwares like a Word, Excel, PowerPoint, graphical information, data analysis, PLM, QMS, WMS. So these are the some of the application layers. So these data management will be supports with this the middleware layers. So in IoT gateway architecture, so first one the device layer. IoT gateway hardware comprises of a microcontroller or a controller. It depends on the application and a requirement of memory, speed, and connectivity modules like a Wi-Fi, Bluetooth, or sensors. So operating system, this is an OS software that runs on the hardware of the programs. This is the system software, so it will be used for to establish the communication. It's like an OS like an Java, Linux, RTOS. It depends upon the gateway applications. Hardware abstraction, so this abstraction allows the software to be developed and controlled independently. So above that OS it will have this hardware abstraction, so this runs to control the hardwares. Next will be sensors and activated drivers. These layers serve as an interface between the device and sensors with the modules. So specific tasks or stacks will be integrated with these layers. Device management and configurations. So IoT gateways needs to keep track of all connected devices and sensors to communicate with them. So these layers track the managing sensor configurations, settings, properties, and connected devices to the ecosystem. Security is a crucial consideration in gateway architecture. This layer ensures the gateways have an trusted identifiers, strong encryption and crypto authentication schemes, and it also provides a secure board for to protect the devices from an intrusion, and then ensure the data integrity and confidentialities. So it should ensure the data should be protected, that is will be secured from the intruder. Somebody is trying for hacking, it should be integrated, have a confidential data that should be protected from them. Firmware over the air updates. So keeping the device firmware, there is a software updates. It should be enable security patches and then updates to increase the security aspects. Communication protocols. IoT gateway protocols are selected according to the amount of the frequency and data communication to the clouds. So gateway needs to connect via cellular mobiles like a 2G, 3G, 4G and 5G, or we can go with an Ethernet, Wi-Fi or any other communication protocols using this TCP and IP protocols. So data management, IoT gateways manage the data from a sensor or a connected devices to the storing that information to the clouds. The data management layer controls the streaming, filtering, data storing, and provides the traffic control of minimize the delays to ensure the device fidelity. Again, cloud connectivity managers. These layer is responsible for seamless, secure connectivity with the cloud platforms to the devices and authentications. That means whenever we have some information that will be stored in a cloud, so cloud connectivity manager takes care of the informations available in the clouds. Custom software application. IoT gateways integrates the custom software to manage the specific application needs. This layer interacts with all other layers efficiently, securely, and efficiently manage the data needs specific IoT applications. So gateway data transfer, this will be have layer will be a gateway connections to the internet using either a 2G, 3G, 4G or any other GPRS modem or IoT modules, or you can use an Ethernet, Wi-Fi or any other internet providing protocols. It also analyzes and determines which data needs to be communicated with the cloud and which data to be cached for processing offline to save the processing power and then plans. See, we have some data will be stored locally, some data will be stored in the cloud. So which data should be stored cloud or which data should be processed locally, so they will be done by this gateway data transfer. Thank you.